Hello students, today we are going to study aromatic hydrocarbons, basically known as arenes. It is classified into benzoid and non-benzoid compounds, So when we are saying benzoid, it means it will be consisting of a benzene ring. And if I am saying non-benzoid, it means it is not consisting of a benzene ring, We can see any examples, some example. So for benzoid, we can take this toluene, So this is basically, I am making what? A benzene ring, What is attached? CH3. This is what? Toluene, And yes, if it is a non-benzoid one, it will not consist of a benzene ring, isn't it? So this is what basically tropolone. So now this is a benzoid compound, toluene, and tropolone is a non-benzoid compound. Now coming to the isomerism, Here it can be of ortho, para and meta type, Here in this you can see one CH3 attached, The first, but the second carbon atom in the second position, And yes, it can be also in the sixth position, like in this you can see here, So if in this position CH3 is attached, So this is the first position, 2, 3, 4, 5, 6. So it can be 1 and 6. So this is also what? Ortho position. So here you can see this is ortho-xylene, this is also ortho-xylene, It can be from this side or from this side, and if you are counting from this side, some other number will come, from here some other. Why? Because if you are counting from this side, this is 2 and here it will be 6, So this denotes the ortho position. Now 1 and 3 and 1 and 5 is the meta position. So here you can count 1, 2 and 3, third position, And yes, if we talk about the fifth position, so in the fifth position it will be coming over here, So if CH3 is attached over here or if it is attached over here, it is what? The meta position, so known as metaxylene, Now, when we talk about the para, here only one position comes, And that is the fourth position, In this, if it is CH3 is attached at the fourth position, it is what? Para-xylene, So this is about the isomerism of aromatic hydrocarbon. So now let us study about benzene, We all know the structure of the benzene, It is like this, isn't it? So who isolated this benzene first time? He was Michael Faraday, And it was seen that this benzene consists of a high degree of unsaturation, Totally unsaturated hydrocarbon, Now, this is a stable, when we see the structure of benzene, this is totally a stable molecule and having how many? 3 double bonds, Now, this structure of benzene, I have written in this manner, But yes, it can exist in these two forms, So this is actually, we are talking about the resonance and the stability of the benzene, ring. Here we can see that this can be represented in this form also and this form, just opposite double bonds, And this structure is also known as what? The Heckle structure of benzene, And as this can be represented in this form or in this form, Here we are seeing that yes, these electrons are totally delocalized, Giving it something, this structure, this dotted structure represents the delocalization of the pi electron. It means that yes, it can be from the either side, And yes, thereby totally giving it a circle form over here, So this structure is representing the delocalization of the pi electrons present in the benzene ring. Now let us study about the delocalization of the pi electrons. Okay, here we can see that yes, here this is the structure of benzene consisting of 6 pi, this 1, 2, 3, 4, 5, 6 pi electrons, isn't it? So here actually these are the pi bonds, and yes, when we talk about all the 6 carbon atoms, okay, they are all sp2 hybridized. Why it is sp2 hybridized? Okay, because they all are connected with this double bond. Okay, now each carbon atom, when I say, okay, one sigma bond, okay, with the other two, here the carbon is present, okay, it has the sigma bond with the other one of the carbon. So totally we are seeing how many of that type it exists. It is 1 into 2, it means 2 bonds we can see, okay, 2 electrons of forming a what? 1 sigma bond, okay, of carbon. Now another 1 sigma bond it forms with hydrogen, okay, the electron of hydrogen. With the electron of hydrogen it forms a sigma bond, thereby 1 is completed. So totally it became 3 electrons of the carbon has been now been stable. Now the third one, it forms the bond, okay, this pi orbital, okay, this one, this forms the bond with the double bond with the adjacent carbon atom. Okay, so here in this we can see that all the 4 electrons of this carbon has now been stabilized. Okay, so now here this pi electrons, okay, this pi electrons or the pi orbitals, okay, they are forming the bonds which are totally in this area what the electrons are totally delocalized. It can form in this manner or it can also move, okay, and thereby this whole forms an electron cloud, okay, over this carbon, okay, and it embraces all the 6 carbon atoms of this benzene ring. Thereby we can see that yes, it can form something like this structure, okay, in this, where we can see the electron clouds totally being delocalized or being spread over, okay, making it what? This structure, a stable structure, giving it what? The minimum energy, and thereby resulting in the stability of this benzene ring. Okay. Now coming to this aerometricity. Okay, what is this aerometricity? Okay, actually this is a property, okay, and this can be formed only by a planar molecule. Okay, it can be a cyclic one or it can be a planar one. Okay, and yes, there should be complete delocalization of the pi electrons. Okay, it means it should be totally in motion. Okay, so now here number of pi electrons, okay, it is calculated by the formula 4n plus 2, okay, in the bracket pi. This n represents the number of rings, okay, it can be from 0 to all the natural numbers, you can take it. Okay, now this presence of 4n plus 2 pi electron, okay, is said to be what? The Heckle rule. Okay, it is said that yes, if there is 4n plus 2 in the bracket pi electrons, okay, it represents the Heckle rule. Okay, and if they are showing what? Aerometricity. Okay, so for example, suppose if we are taking one ring, okay, n is equal to 1. So 4 into 1 plus 2. So 4 into 1, 4 plus 2, it becomes 6. So consisting of 6 pi electrons. Okay. Now if 3n is present, okay, so what happens? 4 into 3. 4 into 3 it is 12. 12 plus 2, it becomes 16 pi electrons in this case. So they are showing what? Aerometricity, and they are following the Heckle rule.